Hey guys, so I've gotten some questions from a couple different people on the actual schematic for the common anode to common cathode converter. So I'm going to take you through that, guys, quickly right now so that you have an idea what it is. So there's about 5 key components. There's your connector with your power and ground. There is your connector that supplies the red, green, blue RGB signal. There is the resistor transistor combos for each color, and I'll get into that in a second. And then there's 2 parallel connections that allows you to connect 2 parallel LED circuits to this particular schematic. So the way you read this is that the power comes in and gets supplied directly to the 2 LEDs because they're common anode LEDs. Then you have your ground signals, which go to each corresponding color. This one is blue, this one is green, and this one is red in my schematic. Down here you have your red, green, blue signals that each provide a voltage to your transistors that allows it to complete the ground circuit. So if you have a blue voltage, that is going to supply this transistor, allow this ground to open, and allow the LEDs here to get power and send ground back to the connector. Okay, again, this is built in such a way that these boxes are kind of self-sustaining. I've tried to identify ways to get each one of these signals, meaning your power ground and your RGB signals, within each area of the car. The reason there are 2 parallel ports here is because one port, for instance, is the window switch and one port is the door lock, but they can be anything you so choose. Down here, each one of these, let's say, conversion bridges or conversion schematics is the same exact part numbers. You have your 10,000 ohm resistor, you have a 100,000 ohm resistor, and then you have your N222A transistor. So this is what the schematic looks like from an electronic standpoint. If we convert this into a PCB view, which I've done, this is a little bit more of a view that you see here, where you see the actual component footprint, you see your connectors, and you actually see your traces going along. Now there are traces on the front and on the back. I haven't fully fleshed out this view with things like mounting holes and things like that because I ultimately don't have a 3D printer or a method of building a container for this circuit board. So unfortunately I decided not to do that, but I did find on Amazon, and I'll link for you guys, a $10 box that has a solderable circuit board, which is right around the right size for this project, as well as it comes with a plastic case and screws that it mounts directly in. If you do want to see what this looks like from a 3D perspective, we can click on this button and it does provide to you a rough view of what this board would look like. So you have each one of your colors here, blue, green, and red. And then you have all of your colors up here listed out. So you have your 2-pin connector, you have your 3-pin connector, and then you have your 2 parallel 4-pin connectors for the LEDs. So again, this is relatively straightforward for people who can read circuits and schematics and build one out. I can help you guys out if you have any questions. This did go through a few iterations, so I'm going to show you guys here. My very first prototype, I tried to make everything clean on the front, so there's no wires on the front of this. However, that put all the wires in a big spiderweb mess on the back. I call it the spaghetti plate. It works. I'm actually using it in the car, but it wasn't clean. Here is actually a view or a picture of the board going into the case it comes in. Now what you do have to do is cut holes in here to allow your connectors to actually poke through, which you've seen in the other video when I showed it to you guys. Down here are 2 other versions, once I started cleaning it up, on what these actual boards can look like if you trace the wires, in a very neat and clean manner. Now you can rearrange this, you can move the connectors around. In this instance, you can see here I have the 2-pin connector on the left and the 3-pin connector on the right. And then I chose here to do the 3-pin connector on the left and the 2-pin connector on the right. As long as you follow the schematic and put these together, you shouldn't have any issues. Now I do recommend when you're going to attach your pigtails of your JST connectors onto your LEDs, I would leave this board open so you can see, okay, here is my 4-pin connector. I need to do red, then green, then blue, then my voltage. Okay? Up here, same thing. Red, then blue, then green. Sorry, red, then green, then blue, then voltage. And so on. The one thing I did opt to do when I moved these around in one of the instances is, if you look here on my 3-pin connector, it's red, green, blue. But on this 3-pin connector, by moving it, I didn't want to have any overlaps like you can see here. Here's an overlap, here's an overlap. I have a blue, green, red, so it's actually reversed. The wire order is reversed. It doesn't really matter, to be honest. These bumps here don't actually impact the way the circuit board actually works, so I wouldn't be concerned about that or worried. I just wanted to see if I could actually create one that worked in a way where there were no actual overlaps, which I did here. But again, I had to make sure that when I built my harness that would pull over my RGB signal, that I would reverse the order of those wires, because the connector ultimately is in the same orientation. So that's ultimately the circuit in a nutshell. If you look here, I did do some testing. So what you see in this photo here is I have a makeshift harness. So here would be my harness from the car, right? An interconnect harness. So this would be what plugs into your door harness. Here you can see it actually plugs into the wire that goes to the map pocket light. So that's the stock LED right there. The wire comes off the side with the RGB signal and goes over here to the 3-pin port. Okay, I have my 2-pin port, which is my power and ground, connected to a 12-volt source that I plug into the wall, again for testing purposes. And then if you look here, I have 2 LEDs tested in parallel. One LED is right here, and one LED is right here. And you can see that all 3 of these are showing the same color, because at this time I only had the pulse wave modulator for the blue turned on. So the color matches. The transistors, if I go back to my circuit, the transistors do turn on and off as quickly as your PWM modulator, which is in the MyColor gauge cluster. I actually think it might be in the body control module, but no worries. It actually turns on and off at the same speed that your stock lighting system does. So you don't have to worry about the colors getting mixed up. At least for the osmium lights that I use, they are the same exact color. So once again, this is the schematic here. If you guys aren't familiar with reading electrical schematics, please feel free to obviously go and look up what some of these symbols mean, but it should be relatively straightforward. This is a very simple schematic, and it probably took me all of about maybe an hour or an hour and a half to put all 3. I actually created 3 after the first prototype. It took me about an hour and a half to create 3 of these all at the same time. So it doesn't take that long. The longest probably time was I used crazy glue to kind of keep these wires neat and clean here, and it works just fine. There's no issues. So I hope you guys learned something new today, and I hope I'll catch you in the next one. Take it easy.